Nice to see you here. So my name is Konstantin Jaskon. This will be just a bit shorter. Just a few words about me. I am an Android engineer in foundational team at CBA now, working on Android science 2010, probably 13 years. Used to work for many companies. For the past 6 years, worked for Egoda, then joined for CBA, and yeah, mostly working on Android stuff, and as well in Egoda, I was as well an infrastructure engineer for mobile, and we built a lot of nice libraries such as Kakao, Marathon, and lots of others. And I contributing a lot to open source. It's my just account. Kakao, Marathon, mostly Danger, who using it. Some libraries as well. But today my talk will be about UI testing. This one. Here we go. As well, guys. Could you raise your hands who's Android developers here? Nice. Because this presentation will be mostly about Android testing frameworks, but as well you can apply the same rules, the same practice to iOS, to Flutter as well. And okay. Agenda for today. So we will talk about deep diving. That's why we need UI testing for application, and as well deep dive to Android specifically, and then some mocks tricky stuffs because it's very important to use the mocks for UI testing, and I explain why and how, and some conclusions. So before we started for the first part, how many UI tests do you have in your projects? 0. Nobody is okay. Less than 100. So stuff like that. Anyway, in CBA we have 1,200, and they was built for past 1.5 years. So the amount of UI testing is growing very fast, and we should to support all this infrastructure for UI testing because we're struggling with a lot of bottlenecks with performance, how to scale it, how to keep a time for execution consistent. But today we will talk mostly about how to write UI tests. And let's go with the first part. So actually, this stuff is a testing pyramid. It's very common. Everybody knows about it. But as well, it can be inverted. But in this one, just unit testing the foundation, because I think if you have, for example, 2,000 unit tests, and we have 200 UI tests and maybe 20 end-to-ends. And as well, unit test is working pretty fast. It's taking less than, can take 2, 3, 4 milliseconds. However, UI test will take up to 30 seconds, for example, can take. And as well, if we're running UI test on a CI, on a test agents, it's taking resources. And for example, if you don't have your own agents, you should run UI test in the Firebase cloud, and you will pay for amount of time. That's all about money. And as well, in this pyramid, I would just want to separate UI feature test and API integration tests and end-to-end test. Most of them kind of UI tests, but it's doing the same. All of them doing the kind of different stuff. And then why we need UI tests and tests in general. So for confidence, if you have some issues in your app, some failures in production, you can just fix it, and then you can cover it with unit, UI test, doesn't matter. It depends of in which layer the issues happened. And then you will never see it again. Continuous deployment, because unit and UI test, it should be a part of required check on CI if you have it. On a GitHub Actions, TeamCity doesn't matter. And it's part of continuous deployments, what will increase. And unit and UI test is a part of continuous deployment. And as well, we can use a screenshot UI test for a screenshot generation. It's a very important part, because if your application translated for different locales, and then you need to generate, for example, for a Play Store, 6 screenshots for each type of device, for a phone, for a tablet, 7 and 10 inches, and then you have a 36 locales, you can multiply it, and it will be more than 600 screenshots, what you need to generate for your release. And UI tests can help with it as well. When you using UI test scenarios for a screenshot generation, it's quite tricky stuff. And as well, it will increase application assessments. Because if your application well tested, you can release it at any time. And for example, in Eguda, whole release process from a cutoff to deployment to Play Store took about 40 minutes. It's quite fast. Because all the features being covered by UI tests and with about 80% of unit test coverage. Quite good one. Let's talk about feature development process in theory again. It's not good to see here, but it's just a 3 layers when you have feature planning in theory. And here you have a discussion of functionality. When your team, with your product owner, you thinking about how the feature should look like, and then you should to decide what's the assessment criteria for this feature. Assessment criteria, it's kind of set of scenarios what needs to be applied for this functionality to be tested, to be automated and tested. And then you have a feature implementation, unit and UI test coverage, unit and UI test implementation. And as a last step, you have a validation by QAs. When all the stuff implemented, QA can run unit and UI test and just to verify that it's covering all the test scenarios. And let's talk about the basic state machine for a basic feature. When you have a loading state, kind of entry point, you open your screen, go into loading, and then you have 3 different states: error, empty, and content. Pretty simple. And then as well, you have navigations. For example, if you have an error, you can reload your screen. And same from empty and from content. And from this state machine, you can think about what the assessment scenarios can be by the connections between the states, and create your assessment criteria. For example, you want to test a loading state, then empty state, reload from empty state, content, reload from content to error, for example, error, reload from error. And as well, if your a new feature going to be a part of application, you also need to verify entry point and exit point from this feature to the other functionality. And I will suggest to you to create if you will follow this way, you can create a abstract test scenario, test case scenario. And this one can be just a YAML file. And in this YAML file, we can declare test case with ID. ID, I will tell you later how we can use it in particular cases. But scenario by itself is just a list of actions. Pretty simple. It's not related for any test frameworks. and just a list of actions. For example, open feature A, wait for content, verify that it's displayed, then list field by three items, and verify content of items. And this one is the end of first part of presentation. And as a result of feature planning, we have a feature logic, how it should work, and as well, it's going together with assessment criteria for a feature. And because it's abstract, for example, in your company, you have an Android and iOS application, and the logic is the same, and assessment criteria for both platforms is the same. And that's why it's written on a kind of abstract language. And then it can be implemented for a platform. Native UI tests. So since we have some Android developers, do you know something about who ever had experience with Espresso, for example? Espresso. Somebody as well. We have a Kakao, Kaspresso. And as well, we have lots of extra frameworks for Android, kind of Barista, but the three is, I think, it's most popular because it's based on Espresso, and Espresso is provided by Google. And when you're writing your UI tests, you should think about how you want to write it, because it can be native tests or a cross-platform. Because all of them, kind of native and cross-platform, have a pros and cons. Native is very fast UI tests. Cross-platform can test a specific functionality, what's not related for content of your applications. And as well, it can be screenshot testing. On Android, we have many different frameworks, and as well, it can be on iOS, it's by default kind of screenshot testing. As well, you should think about how you want to run your UI test. It can be in a local environment when you just running UI test just to verify that your feature works on your local machine, and you can run it on CI on a remote environment. And as well, what the environment in general you have a virtual emulators based on Xeon, for example, processor. Otherwise, or you have emulators on ARMS, because ARMS working for us 35% faster. So you also should need to think about environment and how to scale in the future. That's a very important point, because UI tests time of execution is growing linearly. And you should think about how you can run it in parallel to reduce amounts of time for CI check to pass. And this one is a kind of basic diagram of UI testing frameworks. So if you decide to go for a cross-platform, it's Appium, a native, Android Espresso, iOS XUI tests. Pretty simple. And for Android, we have three popular frameworks, Espresso, Kakao, and Kaspresso. So actually, under the hood, Kakao based on Espresso, Kaspresso consuming Kakao's transit dependencies, and all of them have advantages and disadvantages. For example, if you're going with Espresso, supported by Google, I don't know it's good or not, because anyway, for the past 3 years, it was just one update of Espresso library. Native Android test library, because it's make your UI test run pretty fast. Most popular UI framework for testing, I think, because it's, if you will check how many downloads from Maven you have on Espresso, it will be significant, because it's going to transitive dependency for all the other frameworks, from Kakao, for Kaspresso as well, and fast. Creating lots of boilerplate, the code is unreadable. Depends on API version, what actually it means, because if you're testing the same component, for example, scroll list, on API 23rd, on API 27th, on API 31st, it's based on different classes. And your UI test can fail just because of API version. And as well, with Espresso, it don't provide for you assertion for drawables, for example, for strings, if it's going from resources. But Kaspresso, it just Espresso first one, Kaspresso third one. Kaspresso is a kind of espresso with some extra things. For example, Kaspresso running ADB server under the hood, what's providing for you a lot of extra functionality. You can test your ADB calls. For example, you can create SMS calls, SMS messages to the application, or calls, or change a geolocation. It also contains built-in flakiness control. If you have a flaky test, because actually any test can be flaky, even if it's just empty, and you can rerun it 1,000 times, it's not will be 1,000 pasts. It's pretty fun stuff. And Kaspresso also as well have some flakiness control under the hood. Allure reports. Somebody used Allure reports in your past now? Okay. Allure reports is quite good stuff. Very readable reports for UI testing, for any testing actually. It will provide for you logs, retries when it's failed, if it's flaky, as well some videos, quite good stuff. Step supports, because from time to time your QAs will require for you to create steps in a test cases. For example, step 1, log into your application. Step 2, verify content. And it's based on Kakao. And cons, because it's required to have ADB server, it will create for you some issues when you're scaling it. For example, will be possible to run 2 emulators on the same machine and run Kaspresso on it at the same time, because it's using the same ADB server, and ADB server don't know to which emulators it should send their commands. That's why it's tricky to scale, and it's not will be possible to run it in parallel on CI. That's why we have a Kakao. So first one is example how your code looks like with Espresso, with a pure Espresso, and second one is how the same, actually not the same, it's with descendant off, but anyway, you get the point how it looks like. So to be honest, for me, Kakao is just a much readable, looks like, because it's DSL, and even if, for example, your QAs, if you have a designated QAs in your team, it's much easier to write UI test with the DSL language. And as well, Kakao under the hood providing for you page objects pattern, what's helped to reuse some matchers for your custom view, and as well it's typed page objects, because for each XML components provided by Google Frameworks, we mostly have the same typed for a Kakao. For example, for edit text, you can use K-edit text, K-button as well for button. And that's how it looks like in DSL language. In a second, code snippet. You can open your screen. Screen is a page object, just in general. Page objects, screen can be, it's not about activity. It's mostly about your functionality. When you, for example, have 2 fragments of the same screen, it can be 2 different screens in Kakao, because it can be renamed to page objects in general. And that's how the verification works and how to provide some actions to these frameworks. And what's important is supporting recycle view with a typed items matchers. For example, from time to time, we're using recycle with the different types. For example, you have a header, you have a some bottom panel, and as well some items. All of them is different, but with Kakao, it's easy and it's possible to test it. And as well, for recycle view, it's providing functionality to scroll for selected item. That's actually how the screens looks like in Kakao. And in this example, it's also showing that we supporting Compose as well. It will be, for example, if you decide to move your application from XML to Compose, you're not doing it just in one tick. You should move it step by step, screen by screen. And with Kakao and Kakao Compose, you can write your UI tests for both as well in the same test suite. That's how it looks like. Compose support. And let's back to the first part. We have an assessment criteria with a sample, with a feature, a content test. And this is how the same feature scenario will look with the Kakao. If you can see, actually, it's pretty similar and very readable. Quite easy to understand what's going on there. And if you will have a 7 assessment criteria for a feature, you can just do the same for test scenarios in the Kakao implementation. And as well, Kakao not supporting retries. It's not providing for you functionality with ADB server. However, you can use together Kakao and Marathon. Somebody the Marathon in your projects? Oh, okay. Anyway, it just I think it's right now it's #1 framework for it's a test runner for UI testing. It's not about Android. It also supporting iOS UI testing. But anyway, with Kakao, it's kind of level of responsibilities. Kakao is about how to write UI tests. Also recycle supports, compatibility, API supports, lots of custom matchers for drawable assertions, for example. And Marathon will take responsibility about likeness control. It's also will make your UI test easy to scale, because if you have 2, 3, 4 emulators on your laptop, it will split your UI test suites for these 4 emulators and make it just 4 times faster. Can be integrated with CI, supporting custom configuration. What actually it means? For example, it's not just only for Android. It's a cross-platform test framework. And you can configure your retry strategies, how you want to split UI tests, what the reports you want to have, videos. If UI test will fail, you can also download a video from it, why it's failed, resolve the logs, what will help your developers to investigate why it's happened. And all of this stuff will be provided by Elure reports. It's how we write in UI tests for Android. And the third part is actually it's very important stuff about mocking. Somebody using a mock server, kind of. Okay. In this point, I will try to explain why it's important to have a mock server, and never, in some cases it's okay, but don't test your application on a real data. We should decide what we are testing. It's a feature test or integration test. If it's feature, it's definitely should to use the mocks instead of real API. If it's integration, that's fine to use a real API, but as well, your backend should to have some kind of service account for testing or something like that. Why do we need mocks? Because it will increase the performance improvement. Science, your mocks will be close to your application. For example, you can run mock server inside an Android. It will help your application to work much faster for UI testing. I will explain about it just a little bit later. And test result stabilities. If you have a mocks, what's actually you can customize your mock responses for each UI test, and at every run, your UI test will expect specific data response for just particular case. And control for third-party code as well. For example, you call in third-party API from time to time, and these responses maybe rely on some quota. For example, if you have only 1,000 requests per month or per day, you can just mock this API and use not a real one, but just a mock for a testing. And as well, you should decide about mocks where it should be deployed on some remote machine, or it will be deployed on your own laptop or in the emulator as well. And what's the types of it? It's stateless and stateful. What's actually it mean? Every time when you call in the same endpoint, it's about stateless. Every time you call in some APIs, it will always return for you the same response. But it can be stateful if you updating a status for some values on your backend. Next time it will be different. This is a pros and cons of testing with a production server. Process because it's testing a kind of with a real server, it's testing the whole stack for HTTP, and it's good for integration testing. It's a last stage when you want to test, last kind of check before you're going to release. You want to run your integration tests. However, it will take an extra time for request response processing. It's not sounds bad, but from time to time it can be 100 milliseconds, 150 milliseconds for each request response. And if you're in your UI test, you have 5 requests, 10 requests, it will increase the time for 2 seconds. Not sounds bad, but if you have 1,000 UI tests, it's just up to 15 minutes. And it's stateful. And because it's stateful, from time to time, developers asking us to create how to create branches in your UI test. For example, if some checkbox is selected at this time, we unselecting it, and next run, checking kind of vice versa. That's not how a UI test should work. And how we can move forward with it. So we can create a mock server. This one is application. We have an Android, and in Android, we usually use an OKHTTP for network call requests. And your application going to your endpoint, OKHTTP going to some remote server, what's actually just for debug builds. And this mock server will return a pre-stored JSON mock data. And it still will have some time for response, 100 milliseconds, for example. The huge disadvantage of this solution, you're not able to support the custom error codes. That means it will be hard to test an error state or, for example, throttling issues. When you're updating your mocks, it will require to redeploy your server as well. Extra time for response processing. However, it's stateless. That means you will have stable results for UI tests. Single remote instance. That means your QA can easily test it, or you can upload your application to Firebase and test it as well. And the most important process of the solution is testing whole network stack. However, we can do simplification. Instead of calling a real network stack, we can create an interceptor in application. And how it works, it's just a simple if check. If your request going to your endpoint, it can return assets, what's actually stored in application. It will remove all the network calls at all. And at the same time, it will significantly increase time for your UI test. Easy to implement, quite easy to implement. Fast responses. All the data going as a part of applications. So technically, your application can avoid any calls at all because all the data is preset up in the app and can be executed anywhere. So since you don't make any real calls, your application can be deployed anywhere. Disadvantages: not testing a real HTTP stack, and not shared between platform because Science is just in Android build. It's not possible to share it for iOS. And as well, it's just a next step how we can improve the solution. We can just create a custom test rules for Android to support the custom behaviors. And it can be custom response codes. For example, you want to test, for example, fail scenarios and etc. Supporting throttling. For example, you want to increase the time for your responses. And with these test rules, you can align your tests with your test suits. And this one is an advanced scenario when you as well can deploy Moxova. But for example, with Android, we can deploy so we have a Ktor on Kotlin, and we can run Ktor server inside the Android application, what can create a kind of a local host in your application. And your interceptor for OKHTTP can just redirect all the calls for your endpoint to the local host. And since you have all these custom test rules to support the throttling, to support the test cases, for example, all the calls going to local Moxova. It's require extra effort to implement it. However, it's very stable solution and scalable, and we can just build this Moxova as a independent application and run it for iOS. The same code can be executed for iOS. Pros and cons. Everything's tested. I mean, HTTP stack, mock responses still an app, so going as a part of application. Good for feature tests, because we can test the negative scenarios, all this long loading, and etc. Can be run as a remote server, so the same server can be deployed anywhere, and for example, iOS can use it as a remote server. Stable behaviors for each scenario require lots of efforts to implement, unfortunately, because you should know some knowledge about Ktor, for example, how to store your JSON responses, etc. Unsynchronized it with a production server, so technically your responses can be slightly different, and if you're in active development, if your product in active development stage, when your application and your contract between a server and client is updating quite frequently, it will be really hard to maintain. However, you can use something like Protobuf to have a single source of truth of contract between servers and client, and reuse it for the server as well. And bad for test integration, because test integration require to have some state saving And that's mostly all for today. In conclusion, just want to say a few things. So before you starting to implement your UI test, always think about what you want to test. It's feature tests or it's integration tests, because all of them will require to have a different environment for a best performance. And then you should choose right tooling set. For example, for integration, don't hesitate to use Appium for the features. Espresso. Always, it's very important, I think, to always ask yourself how this code base will be supported and how it will look like in 3 years, for example, in case of scaling. And in the end, do you have any question about Android UI testing?
How do you handle different screen sizes and things and layout? The layout would change from one screen size to the
Espresso is not a screenshot testing, so we don't have it's not a pixel perfect testing.
Yeah.
So you just verify your content, and actually the same test case, if you run on a tablet or on a phone, the results should be the same actually. It's not about pixel perfect. If you want to verify that your test is displayed correctly on a tablet and a phone, then you can use a screenshot testing for it, not Espresso.
what?
Screenshot testing. Yeah.
A CBA test on multiple screen sizes.
Not yet. Maybe in the future, but in a couple of years, but not now.
You tend to find that in your testing pyramid can have that. So the unit test and the UI test. You tend to find that there's any group between those two, where the test is sort of like bring in a bunch of units, component of the form, but it won't depend on buttons, input, kind of.
So you mean it's some kind of unit test, but for view models? Yes.
Yeah.
Yep. But it's actually a different type of tests. It's mostly about unit tests, not UI tests. And we don't have much UI unit test for view models, because we just divided 2 layers, domain logic and presentation logic. For example, in presentation, you have activities, present as view models, and activities as well with the compose. And this area is covered by UI tests. And as well, we have a domain was covered by unit tests. And then we can merge our test coverage together and see kind of what the coverage we have in total. Actually, I think for most cases, I think, yeah, it's notable stuff here.